In this video, I'm going to go over the exponent rules. The first rule is called the product of like bases. That means you have two bases. Remember, you have a base and an exponent. So this number here is called the base, and this is called the exponent. And that means you're going to multiply that base b x times. So the product of like bases would be something like x to the third times x to the fifth. And so you would add those, x to the eighth. So the rule says x to the m times x to the n is x to the m plus n. Okay, the second rule is called the quotient of like bases. That means you've got two bases that are alike being divided. And there are three cases here. X to the fifth divided by x to the third. X to the third divided by x to the fifth. And x to the third divided by x to the third. And you will notice in the first one, the larger exponent is on the top. Well, the rule says x to the m divided by x to the n is x to the m minus n. So we're going to subtract. X to the 5 minus 3 is x to the 2. Now the reason that works is, think about this. X to the fifth means 5x is multiplied. X to the third means 3x is multiplied. And any number divided by itself is a 1. So I'm left with just x times x, or x squared. Now a similar thing happens in the second case where you have a bigger number or exponent in the denominator. We're still going to subtract. X to the 3 minus 5 is going to give me x to the negative 2. But the negative exponent means that the base is in the denominator. So it's the same rule, but a negative exponent is going to end up in the denominator. So watch. X times x times x over 5 bases of x multiplied. Again, we divide these out, we get a 1 over x squared. Well, when we subtract, we get a negative number, and all the negative number means is move the base to the denominator. And that's going to be a separate rule in just a minute. And this last one is x to the third over x to the third. Well, it's the same rule. We're going to subtract. X to the 3 minus 3 is x to the 0. And what we know is that x to the 0 is always 1. X times x times x divided by x times x times x is a 1 times a 1 times a 1, which is a 1. So the quotient of like bases says that you always subtract top exponent minus bottom exponent. But it gives us two new rules too. And that is that is x to the negative n is 1 over x to the n. And it turns out later that if you have a negative exponent in the denominator, it's going to move up to the numerator. So 1 over x to the n, if you have x to the negative n, you put that base in the denominator. And if you have a negative exponent in the denominator, you put that base in the numerator. And that if you have any base to the 0, then that's a 1. And so That's our product of like bases, our quotient of like bases, our negative exponent rule. This is the negative exponent rule. And this is the zero exponent rule. Okay, we have another rule called power to a power rule. And that is going to be a base to a power raised to another power. Like x to the third raised to the second. Well, that would mean I need 2x to the thirds multiplied times each other. And that would mean I have 3 factors of x and 3 more factors of x. So that's x to the 6th. But look, to get from the 3 to the 2 to the 6, we have to multiply. So when you raise a power to a power, you multiply. And then the last rule is the product to a power and the quotient to a power. And these are related to each other. And that means we have something multiplied to a power or something divided to a power. Then the power belongs to both of these. So x times y to the m becomes x to the m, y to the m. And x divided by y to the m becomes x to the m divided by y to the m. So let's do some examples like what you'll see in your homework. Example 1, use the product rule. The product rule says that when you multiply like bases, you add your exponents. So this is going to be y to the 15th because 6 plus 9 is 15. The power rule, number 2, z to the 7th to the 3rd, says that when you raise a power to a power, you multiply. So I'm going to multiply 7 times 3, z to the 21. Now this one has a product to a power, something being multiplied. So it's going to be 6 to the 2 and z to the 4th to the 2. So that's going to be a 36 z to the 8th. Because remember, power to a power you multiply. Product to a power, each factor in the parentheses is raised to the power. 36 z to the 8th. Same thing, number 4. P to the 5th gets raised to the 3rd. P to the 15. Q to the 4th raised to the 3rd. Q to the 12th. Number 5, a quotient or a division raised to a power. Numerator raised to a power, denominator raised to the power. Number 6, I recommend that if you can do anything within the parentheses, you do it first. But you'll notice that within these parentheses, there's nothing that will reduce. There's no x's on top and bottom, no z's on top and bottom. Everything's different. So I'm just going to raise everything to the 2. So be careful. Negative 8 to the 2. Well, that's going to be a positive 64. X squared to the 2. That's going to be an x to the 4th. Z squared to the 2 is going to be a z to the 4th. Y to the 4th raised to the 2 is going to be y to the 8th. So my final answer is 64, x to the 4th, z to the 8th, over y to the 8th. And none of these bases are alike, so I can't do any kind of reducing. Number 7. My base is -4, so I have the quotient of like bases, so it's going to be -4, and I'm going to subtract 8 minus 6 is 2, and then -4 to the second power is going to be 16, because that's -4 times -4. Number 8. I've got some reducing I can do. I've got a 2 on top. That'll go into that 44 and leave a 22 on bottom. So that's just regular fraction reducing. And of course, there's a 1 that's left there, and I may or may not need to write that. My exponents, look, d to the 4th, d to the 4th. Well, that's going to be d to the 0, or 1. And then if I subtract 9 minus 5, that's going to be b to the 4th in the numerator and a 22 in the denominator. My final answer is b to the 4th over 22. Number 9. Any base to the 0 is 1. Now notice this entire base is raised to the 0. So that's a 1. But in this case, this is -11 times 1. So that's -11 because there's no parentheses. The exponent applies only to what's right in front of it, the x. Number 11. Anything to the 0 is a 1, so that's 9 to the 0 is 1, plus 5 to the 0 is 1, plus y to the 0 is 1. The answer to that is 3. Number 12. Raise the numerator, 1 to the 2 over 2 to the 2. That's going to be 1 times 1 and 2 times 2. My final answer is 1/4. Now, in number 13, these are all like bases, so I'm going to add my exponents. So b to the 2 times b to the 3 times b to the 6 is going to be b to the 11th, because 2 plus 3 is 5 plus 6 is 11. So b to the 11th. Now, if possible, I recommend you reduce inside first. So let's see. I see that the 4 will go into the 8 and leave a 2, but u and v will not reduce, so I'm going to be left with a u to the 3rd to the 2 and a 2v to the 5th to the 2. So power to a power, I multiply u to the 6th, and in the denominator, I have to raise this 2 to the 2 and the v to the 5th to the 2. So that's going to be 4u to the 10th. I'm sorry, v to the 10th. 4v to the 10th. Now, u's and v's won't reduce, so it's u to the 6th over 4v to the 10th. All right. Number 15. Let's see. I see x's that will reduce, y's that will reduce, and z's that will reduce. So the 8 has nothing to reduce with, so it's going to stay. I have x to the 4th, x to the 2. I have more x bases in the numerator, so they're going to end up there. I have more y bases. How many more? I have one more. And then z divided by z is just a 1. So my final answer is 8x squared y, because when I subtract the 4 minus 2, I have x2 in the numerator. The 2 minus 1, I have y to the 1 in the numerator. So 8x squared y. And now we have these negative exponents. A negative exponent means move the base to the denominator, then execute the exponent. So look, if I have x to the negative n, I take the base of x to the denominator, then I raise it to the n. And since that's a 1 denominator, that's what goes to the top. And since that's a 1 coefficient, that's what goes to the top. So this is going to be 1 over negative 7 and then squared. Now look, I took the whole base to the denominator. I kept it in parentheses. So that's going to be a negative 7 times a negative 7, 1 over 49. All this exponent told me was that that base is going to end up in the denominator. Be especially careful on number 17. The negative only applies to the x. So that's going to be negative 9 over x to the 5th. Negative 9 over x to the 5th.